So in the yesterday class, we discussed about conservative nature of electrostatic field, right? So there we discussed about electrostatic field is a conservative field. From that, we proved that electrostatic field as a rotational field. Curl E bar equal to 0, we have shown that. And also, for any conservative field, okay, the curl E bar equals to 0 and the closed integral E bar dot dr bar equal to 0 and the work done along the closed path over a closed loop is equals to always 0. So all these things we discussed in the previous class. Now the next concept we are going to discuss is electric potential. So what is meant by electric potential? The concept of electric potential we will discuss here. Right? Till now we covered the discussion of electric field strength. You consider a point charge plus q cell. Okay, then the space around this charge, the space around the charge in which its influence felt is called as what? Electric field strength. Okay, now in this electric field, right, at the point P, which is at the distance small r from the point charge Q, we have to discuss about the electric potential. So first, let us see the definition of electric potential. Electric potential is defined as, right, the work done in bringing 1 coulomb of charge from infinity to a point is called as electric potential. The work done in bringing unit positive charge from infinity to a point in the electric field is called as electric potential at that point. Okay. So ఇప్పుడు ఇది పాయింట్ చార్జ్ క్యూకి సంబంధించినటువంటి ఎలక్ట్రిక్ ఫీల్డ్స్. ఎలక్ట్రిక్ ఫీల్డ్ లో ఏదైనా ఒక పాయింట్ వద్దకు ఇన్ఫినిటీ నుంచి 1 కూలం యూనిట్ పాజిటివ్ చార్జ్ ని పి వద్దకు తీసుకురావడంలో జరిగిన వర్క్ ని మనం ఎలక్ట్రిక్ పొటెన్షియల్ అట్ దట్ పాయింట్ అంటాం. ఓకే, ఎలక్ట్రిక్ పొటెన్షియల్ ఇట్ ఇస్ డినోటెడ్ విత్ ద లెటర్ V cell. It is a scalar quantity. Its SI unit is volt, and the CGS unit is stat volt. Electromagnetic unit up volt, AB up volt. Okay, why? Because the CGS unit for charge is stat coulomb, electromagnetic unit for charge is amp coulomb. From that we are writing corresponding units for electric potential. SI unit volt or joule by coulomb, sir. Volt or joule by coulomb. CGS unit stat coulomb, electromagnetic unit amp coulomb. Electric potential is a scalar quantity. Electric potential is a scalar quantity. Right. So again, let me repeat the concept. So therefore, the work done in bringing the 1 coulomb positive charge from infinity to a point P in the electric field of the point charge Q is called electric potential at that point Vp. Suppose that a test charge Q naught is bringing to the point P. If the work done is W, right, then so what is the work done in bringing the unit positive charge? Okay. So in bringing the test charge Q naught, the work done is W. So therefore, the work done in bringing the unit positive charge, how much? W by Q naught. That is the potential at that point, electric potential at that point. And they infinity నుంచి Q naught test charge ni field లో P point వద్దకు తీసుకురావడంలో జరిగిన work done W అయితే 1 coulomb charge ని తీసుకురావడంలో ఎంత వర్క్ డన్ జరుగుతుంది. సో దట్ ఈస్ W by Q naught. This quantity, this ratio or this fraction gives the electric potential at that. So what is the SI unit for work, sir? SI unit of work is joule. SI unit of charge is coulomb. Okay. So if W is equal to 1, Q equal to 1, you will get V equal to 1. Hence 1 volt is equal to 1 joule by coulomb. Hence I have written here. SI unit is 1 volt or joule per coulomb. CDS unit is stat coulomb. Electromagnetic unit upward. Stat volt, electromagnetic unit is upward. Because here joule by here erg per CDS unit is erg per 1. Erg by stat coulomb gives stat volt. Okay. So similarly, if you take the amp coulomb here, you will get the amp volts. Okay. So this is the basic concept of electric potential. Now, so using this concept, we have to find the electric potential at the distance r from the point charge. ఇక్కడ P వద్ద electric potential ఎంత ఉంటుందని మనము డెరివేషన్ చేయాలి. ఎట్లా చూద్దాం. ఓకే. Right. Again, I am considering a charge plus Q at the point O. Okay. It is the infinity point, right? I consider a point P in the electric field of this positive charge plus Q. Again, you consider point G and point B. The distance between A and B is dx here. Okay. The distance of the point P is r from the point O, where we have to calculate the electric potential. Okay. Now, I am bringing the test charge Q naught from the point A to B. Okay. Actually, so what I am saying is, so the test charge Q naught is bringing from infinity to the point P. So here I consider a small length element, small displacement element AB. So A నుంచి B వద్దకి టెస్ట్ చార్జ్ తీసుకురావడంలో జరిగిన వర్క్ డన్ ఎంత. Okay. So before that, so what I am saying is electric field strength due to the point charge at the point A, where the point A is at the distance x from the point O, sir. So ఇక్కడ electric field strength direction అంటే ఎట్లా ఉంటుంది, ఈ బార్ డైరెక్షన్ ఈ డైరెక్షన్ లో ఉంటుంది. ఎందుకు సార్? ఇక్కడ మీరు 1 కూలం చార్జ్ పెట్టారు అనుకోండి. 1 coulomb charge is positive charge, is positive charge. So the force experienced by the 1 coulomb charge is the field strength. Field strength, the definition you know. The force experienced by the 1 coulomb charge is called as field strength at that point. Suppose that if 1 coulomb charge is placed at the point A, that will be repelled in this direction. So that means what? Electric field strength at this point is along the direction PA bar. Along the direction PA bar. Now I am keeping the unit test charge Q naught at the point E. Therefore, force on test charge Q naught is equal to how much? F is equal to Q naught E. F equal to Q naught E. Okay. Force on test charge Q naught equal F is equal to Q naught. ఇక్కడ ఫీల్డ్ స్ట్రెంత్ డైరెక్షన్ ఇటువైపు ఉంది కాబట్టి ఫోర్స్ డైరెక్షన్ కూడా సేమ్ డైరెక్షన్ లో ఉంటుంది. మరి నేను ఇప్పుడు ఏం చేస్తున్నాను, క్యూ నాట్ చార్జ్ ని ఏ నుంచి బి వద్దకు తీసుకొస్తున్నాను. అంటే అగైనెస్ట్ ద ఎలక్ట్రిక్ ఫీల్డ్, అగైనెస్ట్ ద డైరెక్షన్ ఆఫ్ ఎలక్ట్రిక్ ఫీల్డ్, ఐ am bringing the test charge from point A to B. Then the displacement is here dx bars. Therefore, the work done for the small displacement dx is given by dw equal to, that is minus F into dx, because here the force direction is in this direction. Force F is equal to Q naught E direction. That against the force apply chestunnam kabatti I am writing minus F dx. Okay. So dw is equal to minus, but F is equal to what? Q naught E dx. Okay. This is equation 1. But the electric field strength due to the point charge at the distance x, that is at the point A, electric field strength at the point A. What is the formula? 1 by 4 pi epsilon naught q by x square. It is the equation. Okay. Substitute this value here. Then the work done in moving the test charge q naught to the displacement dx, that is from point A to B, against the direction of electric field. Electric field strength direction ఇట్లా ఉంది. ఎందుకంటే పాజిటివ్ ఛార్జ్ కాబట్టి లైన్స్ ఆఫ్ ఫోర్స్ అన్ని కూడా రేడియల్ అవుట్పుట్ ఉంటుంది. మనం ఈ లైన్ మీద తీసుకున్నాం. ఈ లైన్ మీద ఎలక్ట్రిక్ లైన్ ఫోర్స్ డైరెక్షన్ అంటే టువర్డ్స్ రైట్ సైడ్. సో ద డైరెక్షన్ ఆఫ్ ఫీల్డ్ స్ట్రెంత్ is towards right side. Against the electric field, we are moving the test charge q naught from point A to B. Then the displacement is dx. So dw we have written here. Substituting E value here, dw equal to q naught 1 by 4 pi epsilon naught q by x square dx. Okay. Therefore, the total work done in bringing the test charge q naught from infinity to the point P. Okay. For the small displacement dx, the work done dw. Actually, what we are doing, so we are bringing the test charge q naught from infinity to the point P. Okay. So then we can write the total work done double equal integral, that is infinity to r dw. Okay. So that is w is equal integral infinity to r. What is dw? dw is this one, q naught by 4 pi epsilon naught dx by x squared. So from this you write the constant outside, q naught by 4 pi epsilon naught integral infinity to r. Okay, infinity to r. There minus sign there, minus sign, you write minus sign. Integral of dx by x square. Integral of dx by x square. Minus sign is there. I am keeping the minus. Equal to minus q naught by 4 pi epsilon naught. Integral of 1 by x square, it is minus 1 by x. And applying the limits infinity to r equal to minus into minus gets plus q naught by 4 pi epsilon naught 1 by x, and lower limit infinity, upper limit small. So now substitute the upper limit first, 1 by r minus 1 by infinity, second term becomes 0. Then what you get? Equal to q naught by 4 pi epsilon naught into 1 by r. Okay, this is the total work done in bringing the test charge q naught from infinity to the point P, which is at the distance r. So from this, w by q naught you write as the subject. W by q naught equals to 1 by 4 pi epsilon naught q by r. Already I told you that the w by q naught, work done per unit charge. The work done per unit charge is nothing but potential at that point. Okay. What is the definition for electric potential? The work done in moving the unit charge from infinity to the point, that is nothing but the work done per unit charge. W by q naught represents potential at this point. So that is the potential at the point P. Hence, therefore, this is equal to potential at that point. So the conclusion is electric potential due to the point charge q at the distance r from it is given by 1 by 4 pi epsilon naught q by r. V equal 1 by 4 pi epsilon naught q by r. Electric field strength due to the point charge q at the distance r, 1 by 4 pi epsilon naught q by r square. Electric potential formula 1 by 4 pi epsilon naught q by r. So they are E inversely proportional to x square r square. So here the potential inversely proportional to r. Electric potential is inversely proportional to r. So here మనం ఏం మాట్లాడాం? A small test charge, a point charge, isolated point charge q నుంచి r distance లో electric potential formula ఏంటంటే 1 by 4 pi epsilon naught q by r. Electric potential scalar quantity అంటున్నాం. ఎందుకు? ఇన్ఫినిటీ అంటే ఎక్కడో ఇన్ఫినిటీ అని అర్థం కాదు. ఇప్పుడు చార్జ్ క్యూ కి సంబంధించినటువంటి ఫీల్డ్ ఎఫెక్ట్ కొంత రీజన్ వరకు ఉంటుంది. సో ఈ రీజన్ తో కంపేర్ చేస్తే ఒక డిస్టెంట్ పాయింట్ అనేది ఇన్ఫినిటీ పాయింట్ ఆఫ్ ద రిఫరెన్స్ విత్ రెస్పెక్ట్ దిస్ వన్. సో డిస్టెంట్ పాయింట్ నుండి 1 కూలం చార్జ్ ని దీనికి సంబంధించినటువంటి ఫీల్డ్ లో ఏదైనా పాయింట్ వద్దకు తీసుకురావడంలో జరిగినటువంటి వర్క్ is a scalar, charge is a scalar, the work by charge is a scalar quantity, both are only magnitudes, okay na, only numerical values, no direction. Work has no direction, charge has no direction. There we consider the just magnitude, we measure the quantity only. Therefore the ratio W by Q, the work by charge, is the scalar quantity, right? Okay. Electric potential due to the point charge Q at the distance R, formula 1 by 4 pi epsilon naught Q by R. Right, sir. The next concept is, what is the electric potential when more charges are located in the some region? So this is what we discussed till now. Potential due to a small isolated point charge. Due to the single charge electric potential formula given. Suppose in some region there exists some more than 2 charges. So charge 1 plus Q1, here plus Q2, here plus Q3, something plus Q4, and so on. Okay. Multiple charges are existing in some region. Then we have to find the electric potential at some points P. Okay. Q1 సంబంధించినటువంటి ఫీల్డ్ ఉంది, Q2 కి సంబంధించిన దాని ఓన్ ఫీల్డ్ ఉంటుంది, Q3 ఫీల్డ్ ఉంది, Q4 ఫీల్డ్ ఉంది. సో ఆల్ ఫీల్డ్స్ ఇక్కడ ఒకదాని మీద ఒకటి ఇంటరాక్ట్ అయి ఉన్నాయి, కంబైన్డ్ అయి ఉన్నాయి. Therefore due to the point charge Q, so from the charge Q, suppose if the distance is R1, from the charge Q2 the distance R2, from the point charge Q3 distance R3, so Q4 is at the distance R4. Okay, ఇప్పుడే చెప్పాను. సో పాయింట్ చార్జ్ Q నుంచి స్మాల్ డిస్టెన్స్ లో ఉన్న పాయింట్ వద్ద what is the potential formula? V is equal 1 by 4 pi epsilon naught Q by R. Okay, then according to this, the potential due to the charge Q1 at the distance R1, let us write V1. V1 equal to 1 by 4 pi epsilon naught Q1 by R1. Okay. Electric potential due to the charge Q2 at the distance R2, because the point P is at the distance R2 from Q2. So దీని వల్ల పొటెన్షియల్ ఇక్కడ రాస్తున్నాను. V2 equals to 1 by 4 pi epsilon naught Q2 by R2. Okay. Similarly, V3 is equal 1 by 4 pi epsilon naught Q3 by R3, and V4 is equal 1 by 4 pi epsilon naught Q4 by R4. So what is the net potential there? The net potential at the point P is given by simply the sum of algebraic sum of the potential due to the individual charges. V1 plus V2 plus V3 plus V4. So by summing all these terms, you by taking the 1 by 4 pi epsilon naught common, 1 by 4 pi epsilon naught Q1 by R1 plus Q2 by R2 plus Q3 by R3 plus Q4 by R4. Okay. If there exist many charges in some region, to calculate the electric potential at any point, then simply what we are doing, we are adding the potential due to the individual charges. The net potential at any point is given by the sum of potential due to the individual charges. So using these concepts, let us solve some problems. Simple. How we are applying this concept? So what I am saying is electric potential is a scalar quantity, right? So it has no direction. It is measured in the unit volts, start volt, up volts, right? Electric potential due to the point charge Q 1 by 4 pi epsilon naught Q by R. Right. If there exist many charges, the net potential equal to sum of individual potentials. Okay. Suppose that Q1 and Q2 charges are at the distance 2r, which are separated by the distance 2r. So we have to calculate the potential exactly at midpoint on the line joining them. So midpoint antunnam kabatti Q1 nunchi distance r untundi, Q2 nunchi distance r untundi. Okay. So due to this potential, how much? V1 1 by 4 pi epsilon naught Q1 by r. Due to this potential 1 by 4 pi epsilon naught Q2 by r. Therefore, the net potential at point P equal to V1 plus V2 equal to 1 by 4 pi epsilon naught Q1 by R plus 1 by 4 pi epsilon naught Q2 by R. That is us. Next, let us take. Here I am taking plus Q and minus Q. Plus Q minus Q charges are separated by some distance towards. Okay. Now, what is the potential exactly at the midpoint? They say that is a point P. Since it is total separation to R, so this will be R, this will be R. Okay. I think it is electric dipole. What is electric dipole? The combination of two equal and opposite charges which are separated by some distance. That system is said to be electric dipole. I explained that in the previous class. Plus Q minus Q. So what is the net potential exactly at the midpoint? Due to the plus Q potential here, V plus is equal 1 by 4 pi epsilon naught Q by R plus Q by. Due to the minus Q charge, the potential V minus is equal 1 by 4 pi epsilon naught minus Q by R. Okay. If there is a plus, you write as it is plus. If there is a negative charge, take negative side. The net potential at that point is equal to V plus V minus. So these are the same terms, but here plus and here minus and you will get 0. Okay. I think you know this is what is this? It is equipotential line. Okay. This is electric dipole. This put electric dipole is dipole axis. దీని ఏమంటాం ఈక్విటోరియల్ లైన్ అంటాం ఎలక్ట్రిక్ డైపోల్ యొక్క ఈక్విటోరియల్ లైన్ ఓకే సో దీని మీద ఏ పాయింట్ తీసుకున్నా మీకు పొటెన్షియల్ 0 అవుతుంది ఫర్ ఎగ్జాంపుల్ నేను ఇక్కడ పాయింట్ తీసుకున్నాను అనుకోండి సార్ ఇక్కడ నుంచి ఇక్కడికి ఎంత డిస్టెన్స్ ఉంటుందో ఈ డిస్టెన్స్ అంతే ఉంటుంది కదా సో డ్యూ టు దిస్ పొటెన్షియల్ ఇది x అనుకోండి ఇది కూడా x ఏ ఉంటుంది ఎందుకంటే ఎగ్జాక్ట్ గా మిడ్ పాయింట్ నుంచి పోయే వెర్టికల్ లైన్ అన్నమాట దిస్ బైసెక్టర్ లైన్ ఇస్ exactly this is the vertical line passing through the midpoint and perpendicular to the dipole axis. So therefore any point on this line, any point on the equatorial line which is at equal distance from plus q and minus q. But ఇక్కడ నుంచి x distance అయితే ఇది కూడా x అవుతుంది. Hence potential due to the plus q 1 by 4 pi epsilon naught q by x. Potential due to the minus q, you will get minus q by x, 0. Net potential at that point is 0. Hence, at every point on this equatorial line, the net potential is 0. Therefore, this is called equipotential line. Equipotential line. Okay, equipotential line. Right. So, using this concept, I will use one more problem. This is an equilateral triangle, sir. Okay. At two corners, plus q and plus q are placed. The side of a triangle is say small a. So what is the net potential at the third corner? This is the question. Now, since the side of the triangle is a, here also I have written a. Due to the plus q here the potential V1. Due to the charge plus q, the potential at this point V2, right? Since the potential is the scalar quantity, the net potential at that point equals simply the sum of these two potentials. Therefore, net potential at that point Vp equal to V1 plus V2. Okay. that equal to what is V1 from the point charge Q at the distance A. What is the formula? 1 by 4 pi epsilon naught Q by R. So here Q by A plus, it is also at the same distance, hence 1 by 4 pi epsilon naught is common, Q by A. Okay. Equal to 1 by 4 pi epsilon naught 2Q by A. 2Q by A. Okay. Just I am changing. This is plus 2, it is minus 2 now. What is the net potential at the third corner of the equivalent triangle? Due to the plus 2, you will get here Q by A. Due to the minus 2, you will get here minus Q by A. Cancel. It gets cancelled. Then the resultant potential at the point P will become 0. Okay. You take a square, a circle. Circle of radius some r. On the circumference is some 3 microcoulomb and for minus 5 microcoulomb, 6 microcoulomb, some minus 4 microcoulomb are placed. What is the resultant potential at the center of the circle? Question is plus 3, minus 5, plus 6, minus 4 microcoulomb are situated on the circumference of a circle of radius something 10 centimeter, r equal to 10 centimeter given. Find the resultant potential at the center of the circle. This is the question. Scalar. Electric potential is a scalar. Don't confuse. To calculate the electric field strength, we have to consider the direction. Here you don't talk about the direction. Simply, the net potential is equal to the sum of potential due to the individual charges. V1 plus V2 plus V3 and so on. That's all. Just keep that point in your mind. So here Q1, Q2, Q3, Q4 are all at the same distance because on the circumference equal distance R, right? So net potential is given by at the center V1 plus V2 plus V3 plus V4 equal to, due to the point charge Q at the distance formula we have 1 by 4 pi epsilon naught Q by E. So here 1 by 4 pi epsilon naught taking common Q1, that is 3 microcoulomb, 3 into 10 power minus 6 microcoulomb, changing into the coulombs. Okay. By A, radius how much? 10 centimeter, changing into meter, 10 power minus 1, 10 into 10 power minus 2, plus Q2, minus is there. Minus and you have to take the minus and say minus 5 into 10 power minus 6 by 10 power minus 1. This plus 6 into 10 power minus 6 by 10 power minus 1. It is again negative charge. Minus 4 into 10 power minus 6 by 10 power minus 1. Okay. So this is equal to 1 by 4 pi epsilon naught value. You know, this is 9 into 10 power 9. In all fractions, 10 power minus 6 is common. So write 10 power minus 6 common. In the denominator, 10 power minus 1 is also common. Take that one. Here 3 minus 5 plus 6 minus 4. Okay, sir. 6 plus 3, 9. 9 minus 9, cancel. Equal to 0. Common sense you can apply here. So positive charge plus 3 microcoulomb plus 6, total 9 microcoulomb. Positive charge. Negative charge minus 4 minus 5 minus 9. So positive charge 9 microcoulomb, total negative charge minus 9 microcoulomb. Both are at the same distance from the point O. So the potential due to the plus 9 microcoulomb, potential due to the minus 9 microcoulomb gets cancelled. Therefore, net potential equal to 0. So itla meeru itni sum cheskoni kuda net potential resultant value Q1 plus Q2 plus Q3 cheste resultant charge anta untundi dani batti direct answer raseyoచ్చు. Okay. So like this electric potential concept దాన్ని ఎట్లా అప్లై చేస్తున్నాం అనేది మీరు ప్రాబ్లమ్ సాల్వింగ్ లో ఈ కాన్సెప్ట్ ఉపయోగించవచ్చు. ఓకే. సో వాట్ ఐ యామ్ సేయింగ్, సో డ్యూ టు ద point charge plus Q at the distance R, electric field strength formula 1 by 4 pi epsilon naught q by r square. Okay. But the potential formula 1 by 4 pi epsilon naught q by r. Field strength inversely proportional to r square. Potential inversely proportional to r. Electric field strength, for example, at this point, you keep the unit positive charge. So this 1 coulomb charge can be repelled in this direction. Here we are talking about the direction. E bar is a vector. The direction is along the direction of repulsive force, along the direction of force acting on the unit positive charge. But there is no direction for V. That is a scalar quantity. So how we are defined? How we define electric potential is nothing but say for example, this is the electric field of some charge Q. Electric potential is defined as from infinity to a point in the electric field. So what is the work done? The work done in bringing the unit positive charge from infinity to the point is called electric potential. So in the same electric field, point A, this is point B. So the work done in moving the 1 coulomb charge from A to B is called potential difference between these two, that is VAB. Okay, potential difference is defined as the work done in bringing the 1 coulomb charge or unit positive charge from one point to another point in the electric field is called potential difference between these two. Okay, so what is the SI unit? 1 volt. 1 volt equal to 1 joule by coulomb. So we can define volt also. If the work done in bringing the unit positive charge from infinity to a point is 1 joule, then the potential at that point is 1 volt. 1 coulomb charge ni infinity నుంచి ఫీల్డ్ లో ఒక పాయింట్ వద్దకు తీసుకురావడంలో 1 joule వర్క్ డన్ జరిగితే then potential at that point 1 volt అంట. సో ఇక్కడ పొటెన్షియల్ డిఫరెన్స్ పరంగా ఎట్లా డిఫైన్ చేస్తుంది? ఎలక్ట్రిక్ ఫీల్డ్ లో ఒక పాయింట్ నుంచి వేరే పాయింట్ కి 1 కూలంబ్ చార్జ్ ని మూవ్ చేయడంలో 1 కూలంబ్ పాజిటివ్ చార్జ్ ని A to B కు మూవ్ చేయడంలో జరిగిన వర్క్ డన్ 1 జౌల్ అయితే then the potential difference between A and B equal to 1 volt. Okay, electric potential అంటే with reference to the infinity చెప్తున్నాం. ఎందుకంటే electric potential at infinity point we are taking 0, V infinity equal to 0.